now going to move on to the Krystyna Johnson Award, and we should have Jim joining us via Zoom.
The Krystyna Johnson Award was set up in 2003 when my wife, Krystyna, died far too young, but we decided in SEDA that we would try and remember her with some kind of student scholarship, which originally was a travel award, but changed over the years. Krystyna was an architect who worked mainly in refurbishment, restoration. She worked for Assist on the Glasgow tenement in the early days of the Glasgow tenement that we heard about yesterday from the MSP. She then became the first in-house architect for a housing association and continued to do a lot of refurbishment work, rehabilitation. And this we're talking about basically putting bathrooms in Victorian tenements that were having to share a toilet on the stairs. And she developed her career, but she was always very aware of the necessity to conserve resources of all sorts. She'd lived through the Nazi occupation of Warsaw, when she must have had extreme shortages of food, clothes, heat, warmth. She survived that to eventually escape to Britain, where I met her. So she was very aware of the limitation to resources, and that I think led us to join the embryo SEDA in its first meeting in 1991. We were two of the first members, and she continued helping. I think she was actually membership secretary, unpaid and everything, of course, for a long time. Anyway, so we decided to set up the award, and this has been continuing for the last, 6 or 7 years in the format that we have now, which is an award to second year students. The intention being to try and encourage ecological thinking fairly early in their academic career. So I think that's probably enough to say now. If you want to, I think we're going to see presentations by each of the students now, the 5 shortlisted students for this year. And I've had the advantage of seeing their schemes for the last couple of weeks. So I have a good idea, and I can tell you that the standard is very, very high. For me, as an ex-teacher, it's astonishing what second-year students can do now. So I think we should go ahead and see their presentation.
Okay, so the first student to come up is Rona.
Hi, I'm Rona Bissett and I'm from Edinburgh School of Architecture. So yeah, this is my project. There we go. This is Collective 24, so it's in Bellevue in the northeast of Paris. So as architects, I believe we have a responsibility to reduce this 40% global energy consumption and 30% greenhouse gases emissions that building sector accounts for. Through my passive strategies and environmental analysis to create this sustainable neutral design, I feel like I have addressed this. The staircase separates the public from the private domains so that the artist residents can observe, create and connect with the artist community in the neighbourhood. Currently in Bellevue, the artist community is declining as expensive developments are popping up, leaving the artists unhomed and creating art squats which create an unhealthy, uncomfortable environment. The community is struggling to survive, so this is being created so they have a better quality of life and through the co-living apartments can socialise together and connect while having that artistry. My proposal is situated in a 15-minute city, so it encourages the residents to explore the community at night, especially because the natural light in the building is reduced through the building. So it encourages the residents to explore. That's creating the social interactions and better lifestyle for residents and neighbours, altogether reducing the CO2 emissions of Paris. So how I did this was I used an in-depth light analysis that indicated the thermal mass of my main building material, CLT. This helps reduce the energy cost and the carbon cost by 70.8% compared to a normal concrete building. Alongside this, the natural light helped me indicate where my room schedule would be. So when divided up by private and public, it helped me create my living to my bedroom spaces. When the thermal mass absorbs too much heat, I added offsets for the double height windows in the living area so that in the summer it creates a shade but also has cross ventilation from windows to the vents, and the vents enter through the staircase. Yeah, I carried out rough analysis to figure out the numbers and embodied carbon. My transportation factors emit 400 kilograms of CO2, and through the use of using Auner's cordata trees, this offsets the carbon by 240 kilograms of CO2 per tree, which I've used around my staircase and on the garden. These trees are grown in a process called agroforestry. Agroforestry creates a microclimate for the farming and produces more yield and protects the crops. And then the main material is the cross-laminated timber. Emits 75% less carbon than concrete and also holds hygroscopic properties. This can be easy to repair and use into biomass or new buildings, like the London V&A Courtyard Pavilion in 2018. However, if this building was situated in Scotland, it would not be liable because there's a CLT plant in Paris which I have used, and in Scotland we do not have one yet. So the carbon neutral design of the air miles costs 6,803.44 kilograms of CO2. So each tree the trees are located at my roof garden, and this is a 1.9 metre thick roof. There's a delayed drainage system so that the urban setting is not flooded in climate change, and contains 7 layers of water permeability and prevents water damage and controls the moisture. My intensive roof U values are 0.07 with the max limit in Paris of 0.19. It also has a hybrid 95% recyclable solar panels, which creates 1,000 kilowatts a day, which approximately on average houses monthly energy use. All in all, my design works well in context and enables a healthy community that it creates artist community too. helping with the responsibility to reduce that 30% greenhouse gas emitting from the building sector. Thank you so much for listening, and if you have any questions later, I'll be at the back.
So, I'd now like to invite to the stage Marco, please.
Hello, my name is Marco. I come from Robert Gordon University, and I would like to just present you my project. So, the first thing is I want to say is when I was a kid, I used to run in the back of the seat of the car of my father or grandfather back in Venezuela, where I was born. And I used to see all these construction spaces, and I really hated them. So I really thought that architects were mean people. Until I started studying architecture, and I actually, you realize that it's a bit more than that. So what would happen if we allowed nature to take back what, we're taken from her? So I started with my project. It's in the city center of Aberdeen, and it's a derelict space. As you can see, it's in a very busy area. There's a lot of shops and a lot of activity. It's also one of the worst streets in Aberdeen. It's very insecure, and there's a lot of people homeless in the streets. Not a lot, but quite a lot. So I started to kind of tackle how I could change a little bit the environment for these people. You will see in further slides how I can do this. So I started with new materials that can be less expensive, lightweight, and had for example, a scientific interest, which is very important today. So the first thing that I tackle is the morning light, which is a very important thing in Aberdeen. In Scotland, we don't have much sunlight throughout the year. So I thought the morning light was quite a special thing to focus on. And also the single person homelessness and mental health in the Aberdeenshire area, which is also a big thing at least for that I can see that's happening in this area. So first, I started with some data-driven design. I used Grasshopper and Ladybug to kind of determine, how my building would work. I didn't consider the volume of clouds throughout the year, of course, which is 10 months out of 12 months, we're cloudy days. And I really, from my background, I studied a bit of art before, and so I was very inspired by this concept of komorebi. It's a Japanese concept of how the light goes through the leaves, and this creates a mystic kind of environment that keeps you awake. And also the site-specific problematics that I think architecture should focus a lot is something that we're kind of missing in architecture is the site-specific designs. I think architecture should be site-specific. Certain cities have certain problems that should be addressed, and all the designs cannot be the same. In some instances, yes, but so in this case, I have tried to tackle single homelessness and hidden homeless, which is also obviously, as we know, a political problematic, but how we can address it through architecture. So I just want you to, as a quick exercise, to imagine yourself. You're in a room with 4 walls and a ceiling and a floor. So imagine that this room is gray, the ceiling is gray, and the floor is gray. We are in Aberdeen. And it's raining and it's cold. So it's a bit of a big heritage for us to be the granite city, but it's also an intrinsic problem that it affects the mental health of the people that live there. So you have everyday gray walls, same kind of monotonous facades, and this kind of affects us, and we kind of forgotten about this. So for my design, this is just a bit very quickly over it. So I tried to design 3 types of flats, 1 bed, 2 bed, and 3 beds, and how strategically I can add certain spaces. I don't know if you can see the mouse. Yeah. To add, terrace areas and dens inside the flats for people to kind of, not live in this, the rooms all the time and get outside. So for the visual strategy, I've tried to use moss and this Japanese kind of Zen gardens strategy to drive the people into the garden from outside to the inside and vice versa. I just want to ask you, do you think Scottish cities look like this at all? And this also would help for the urban heat islands, to be effects to be tackled. I just want to touch very quickly on these wastewater heat recovery systems for my building. I don't use any bathtubs at all, so this is, for the sake of trying to save CO2, which is a massive, an important thing in this project. It's over 2 tons of CO2 saved per year, only with the heat recovery systems. And as I mentioned before, the urban heat islands are also diminishing or increasing the temperature, depending on if it's summer. It will be less hot for other cities, for example, like Madrid or Barcelona. This would help a lot. So this is my my final slide, my poster slide. This is the one I presented for this competition. So I'm using, as you can see here, it has 2 parts. The top one, it's a mycelium interior design that I've created for interior, like indoor spaces, public spaces. It's a modular design I have created with Grasshopper, and it has many things. It has the mycelium, it has the soil, and it has the springtails, which I have back there with my models are. They are alive, and they keep all this microsystem alive, and you don't need any maintenance, which is one of the other problems that I was trying to tackle. The green roofs are very expensive to maintain. Green walls are expensive to maintain, and it would be, without this having to maintain it. And the bottom one, which is the mycelium has both thermal and protective layers, which is built for disassembly kind of approach. And I will be at the back if you would like to, ask more questions. That's my time. That's up.
So I'd like to invite to the stage Caitlin, please. It's all yours.
So I'm Caitlin. I'm from the University of Strathclyde, and the project I'm going to be presenting today is my Year to Share project, which is the design of a student study library in the town of St Andrews. And I'll quickly kind of go over the design process and kind of how the building responds to the site, as I think it's one of the most important things about the building. So St Andrews is obviously a town known for its traditional sandstone buildings and kind of old cobblestone streets, but there are so many green spaces that are only really known by the people that live there due to so many of them being hidden away and closed or even forgotten about. So my project kind of aims at looking at ways to appreciate these spaces more, and then highlighting the importance of views and vistas around the town of St Andrews, and incorporating these into a library environment where I think they should be more important. So the aim of the library was to respectfully create a modern study environment in quite a busy corner of the town by connecting green spaces and encouraging the sharing of knowledge in this new community space. The concept was a direct response to the brief, but most importantly the context that is in, with priorities placed on the environment, circular economy, and user comfort. The creation of outdoor seating, green terraces and courtyards kind of made Union Street more of a destination and not just a route, and kind of just created interest for not only the library users but for passers-by as well, as it is such a populated area. There was also an importance to make sure that the building sat cohesively within its context. So by stacking the spaces, which you can maybe see better in the next slide, the library doesn't sit too harshly on that site edge, and then the use of quite a modern construction material and the curtain wall in it also just creates quite a permeable facade and doesn't become too overbearing on the site. So like I said, the Union Library was designed to encourage the sharing of knowledge, which I think is reflected a lot in the organisation of the plan. The building is arranged in a very open plan style, with the public and private spaces being quite carefully thought out and deliberately placed within the building. The idea was to have a large foyer space to accommodate from people coming in from both of the main entrances, and then a kind of grand feature staircase that kind of acted as an additional, more informal place for people to kind of study, read, and just chat and kind of connect the library users to the space a bit more. I won't go over all the spaces, but the reading room and the bookshelves have been placed on the first floor, just at the top of the stairs. Just the books out of any direct sunlight, and the library users are kind of guided here by the position of the stairs, as well as the skylights that are above. And I think also the layout of the bookcases kind of help lead your eye up as well and then round onto the first floor. There is a central void that acts as a way to connect all the spaces, as well as views out to the courtyard and over the town. That's also kind of everything around the library is kind of designed around that, as well as the natural light that enters the building. There's also space for a visiting academic that's been placed kind of at the front of onto the street. That kind of, the idea of that was to replicate the way the residences on Market Street are placed above the shop front, so that's kind of how that came about. So as you walk into the library, I wanted to create a really welcoming and calming environment, which I think is not only done by the use of natural light, but the use of quite a simple material palette, which is very different to the other buildings in St Andrews. The library not only has spaces and places for personal study, but overall it kind of creates a space for people to come together as a group and appreciate those wildflower planters in the courtyard spaces. The goal was kind of to allow as many spaces as possible to have direct access to a green terrace or to the courtyard, just creating quite a seamless connection between indoors and outdoors, which I think is quite important in such an urban location, and just to allow library users to kind of recharge and take a step back from their studies and provide a place for them to do that. So along with the creation of a new community space within the town, the materiality was obviously quite an important factor in the sustainability of the project, but both of these things kind of went hand in hand with the atmosphere I wanted to create anyway, so it worked out quite well. So I've got a CLT and glue lamp structure, which kind of, I thought about the circular economy, which worked quite well with that as well. But it also kind of, again, tied into the atmosphere and created quite a peaceful entrance, and then that also continued onto the inside. There's obviously the green roof that's increasing biodiversity, but also reducing noise pollution. And yeah, there's a section of the building that's in sandstone that kind of acts as a transition between the old buildings on Market Street and then into this kind of sort of oasis corner of timber. And the kind of idea was that the use of timber only really reveals itself as you get closer to the building, which I think kind of hints at the initial idea of those hidden green spaces, even though now those once hidden green spaces have now been brought to the forefront of kind of like a urban library design that's quite modern. And yeah, that's me, I think. Thanks for listening.
Thank you very much. I'd now like to invite to the stage Ailsa, please.
Hello everyone, my name is Elsa Hutton and I study at the Mackintosh School of Architecture. This is my project Within the Earth, which is a adaptation design on the Bowness Library, which focuses on a material investigation. So to begin with, I started with 4 principles. First being earth, where I considered soil and its natural resources on the land. Then water, looking at water's interaction with our landscape and further understanding its properties. People, to understand how people interacted with Bowness's infrastructure. And finally, quality, how to improve the quality of life by improving the quality of a building. So, Bowness is not the most economic site, I would say. It's fallen short to quite a lot of economic decline in the past. There are lots of disused buildings, which is where I started to think about reusing these brownfield sites for their building materials, such as timber, stone, etc. However, when I looked closely, I actually saw how nature then reclaimed these sites, which made me consider how to use nature and architecture as complementary elements instead of contrasting ones. So firstly, I wanted to investigate the geology of the land in Bowness, where I discovered that Bowness actually has a lot of marine clay deposits near the surface. And this interested me because it meant that there was more potential to use these building materials. I then went on to research plants found locally in the area and found that eelgrass seaweed is found in the Firth of the Forth, which is important for later. To begin my material research, after learning that there was a lot of clay at the top of the surface, that really excited me, as it meant that rammed earth was an option. Each sample of this rammed earth has a different ratio of soil to plaster, because I wanted to see how well it could hold together using as little binding agents as possible. And I also found that you can make cuts out of it for windows and doors. The eelgrass that I found in the river is one of the most common species used for seaweed insulation. So I collected some that had washed up on the shore, more just to understand how to use the material. Firstly, I made a model of the seaweed insulation panels to get an idea of scale and size. And then I went on to mix crushed seaweed with agar flakes, which created a bioplastic, and this was more just to understand how much potential this material has that we've not yet thought about. So after the natural resources, I then went on to look at the industrial decline of Bowness, which seemed to be linked with the well-known beaching report in the 60s. This disconnected lots of small towns within the UK. Due to this, I actually did find a lot of scrap railway materials throughout Bowness, and railway tracks look a lot like I-beams, which are used to hold up buildings, I guess. You all know that. So then I thought about recycling these scrap materials using urban mining for the structure in the building. So a turning point in my design was understanding how to use the focal point of the rammed earth more realistically. So initially it was going to be like an aesthetic feature within the building that helped with ventilation and air quality. However, this made the spaces like less adaptable, and it also decreased the amount of natural light you could get there. So to resolve those issues, I really started to consider using rammed earth within the wall envelope, and this is quite a difficult concept to try and understand, especially with the Scottish climate. Rammed earth and water are not a great mixture. So my design overall is a loose fit community space. It maintains the library function with a cafe area and a library area combined. It has a lecture hall space in the basement, an event space on the first floor, and a quiet work area on the ground floor. My goal for the overall design was to create a space which gives local people opportunities currently not available to them due to Bowness's infrastructure. I achieve this by creating a loose-fit space that can be adapted easily. One example of this is the curtain system that I have in the lecture hall basement area, as well as the double height ceilings on the first floor so that more activities can be done there, such as like sports and whatnot. To come back to the curtains, these were inspired by the MAAK Architecture Foundation, where they replaced drywall with a curtain system in a community centre to increase space adaptivity. I was inspired by this project, so to source the curtain, I was thinking about involving the wider community by asking local schools to teach students how to make patchwork squares for this quilted curtain, hopefully meaning that the community would have a better connection with the library and increase community engagement. So coming back to these 4 principles, I discovered that earth, water and people were all connected to give the quality of the building. So the materials provided structural quality and air quality. The biomaterials also increased the ethical quality of the design in terms of sustainability and carbon emissions. The quality of life for the people in Bowness would also improve as the design provides social development, education about biomaterials, and most importantly, it provides space for people to enjoy. And just in conclusion, using materials as a focal point for this project really helped me design with care. The style was really formed by the limitations I set for myself at the beginning. It's almost like when you need to cook the dinner, but you've only got the ingredients you've got in the cupboard. The design is really aimed to work holistically, taking care of people, using it just as they've taken care of its environmental impact. And it shows massive potential for what nature has to take care of us, just as long as we take care of it. And overall, I really think it is a design of life itself. Thank you very much for listening.
I'd now like to invite to the stage Andrew. All yours.
Hi everyone, my name is Andra Tai, and today I'll be presenting my Year 2 project, which is the RSPB Lochwinnock Nature Centre. So this is RSPB's main visitor site in Scotland, and it's within easy reach of the population of Greater Glasgow and has direct rail connections with Glasgow and Irvine. It has a long history of educating people about the environment and also connecting people with nature. But over the recent years, it has suffered from a lack of major investment, leading to the decline in the number of visitors and ultimately the loss in the potential of what such a great site can offer. So the brief that we were given was to redevelop and replace the existing nature center and create a place that aims to protect not only the existing site, but also ensure the inclusivity of all visitors. Whilst designing this project, there was a strong emphasis on supporting RSPB's mission, which was connecting people with nature, and also integrating sustainable energy design solutions in our building design. So the concept of my project can be explained in 5 different concepts. First is the response to site. So the building takes an angled form to protect the existing trees, and there's a central courtyard that is cut out to bring in light into such a deep floor plan and also aid ventilation as well. So secondly would be the volumetric layout. The layout responds to the functional and spatial relationships between the building spaces, and it also creates coherent circulation within the site. Blocks to the right of the building are slightly angled towards the right to create a new view perspective. Thirdly would be the creation of paths. There are 2 main access paths that have been created, and these access paths articulate the building into 3 main sections. The circulation of the building is actualized through the fluid interconnected areas. And fourthly is the structure. So much of the timber structure of the building is left exposed on the interior and exterior, and the curved beams of the building support the sloped roof. Finally would be the sloped roofs. Sloped roofs are an ideal surface for rainwater collection, and it also allows for window openings, which allows low winter sun to enter the building during winter. So a key aspect of the project is protecting biodiversity, and the ecological diagram below shows the rich and diverse wildlife that can be found on the RSPB site, and also emphasizes why it's so important to protect the RSPB site. The diagram above, which is the exploded axonometric, visually represents the main components of the building and the materials used. So curved recycled aluminum roof plates will be used for the roof. This will help direct precipitation into the rain gutter, allowing for rainwater collection and storage. These roof plates will be made from recycled aluminum, which is recycled from post-consumer scrap aluminum, which are taken from facades and windows that have been dismounted from buildings. Secondly would be the beams and timber columns that will be made from locally resourced Scottish larch. This will reduce the transporting costs and thus reduce the embodied carbon of the building. Thirdly would be the south-facing skylights, because the direction of the sun is coming from the south. So this will allow natural light to enter the space because, as mentioned, it's a very deep floor plan. Fourth would be the louvered facade at the back. This allows protection against solar radiation, but still allows light to diffuse into the space. The high ceiling of the room prevents heating during the summer and also improves ventilation. Moving on to the floor plan, upon entering the reception, you're greeted by a direct view into the marshland, which invites and engages the user into the space. The corridors of the floor plan is divided into two main circulation paths, as described before, one on the right and one on the left. The left provides the staff easy access to the key areas of the space, such as the learning center, the staff toilets, the offices, and the drying room. And the circulation path on the right leads visitors to the main viewing and exhibition area, the cafe, and the stairs leading up to the first floor, which is the viewing deck. The service spaces are strategically positioned in the central portion of the building. So the toilets and the kitchens are positioned in the central part of the building to allow for easy location and access, and also makes for a more efficient space. So moving on to the first floor is the viewing deck. It offers an elevated perspective for bird watchers, giving them a broader view of the marshland. The cut-away axonometric gives a clearer view of the building's internal spaces. So green areas around the building contribute to purification and cooling of air, and also protects the facade from solar radiation. During the winter, the building is warmed by winter sun and is heated by simple passive gain when sun angles are low during winter. And it is also shaded from the summer sun during the summer. Because it's shaded from the heat and the glare during summer, it regulates the building temperature and also significantly reduces energy consumption costs for cooling. The window openings also allow for ventilation through the stack effect. They facilitate passive cooling during summer with low maintenance costs and with little to no energy expense. And a huge part of this concept was to recycle and reuse bricks from the demolished existing building to be used as a vibro-compacted brick. These vibro-compacted bricks negate the use of concrete pile foundations and thus reduces the environmental impact that this building has. I wanted to implement a terrace wetland landscape as well for the purification of wastewater. So surface water is collected from surrounding areas and is discharged into a linear watercourse and harvested for domestic reuse. Wastewater is then brought into the sewer and is purified through biopurification terraces with the use of marsh plants. Purified water can then be utilized for irrigating and subsequently returned to its natural water courses. Whilst having our discussion with the RSPB, they mentioned that we had to refrain from using solar panels because of the glare that it might cause for the migrating birds. So the only viable option was to have heating from geothermal sources. Yeah, okay. Can I conclude? Okay. So in the last slide with my renders, I wanted to create an inviting and engaging space for visitors all over Scotland to want to engage and connect with the environment, and paying a lot of attention to the nature and sensitivity of the timber, because throughout the year the Nature Centre will receive different qualities of light, which allows the play of shadow and light. Yeah, thank you. Thank you.
We've been looking at these very good submissions. Very, very impressive. All 5 of them are very, very impressive. I've had the chance to look at the schemes in detail over the last 2 weeks. It seemed to me that they could fall into 2 classes. There's what I would call the detailed building design. That's the Parisian schemes, the St Andrew's Library and the Loch Winner, where we have a very clear architectural end result. The other 2, the homeless housing in Aberdeen and the Bowness Library, have developed a lot of very, very interesting ideas, and the kind of commitment in Aberdeen to doing something about the homeless situation, very impressive. The investigation in Bowness of the possibility of using the seagrass for insulation is interesting. However, when we looking at them all across the board, my own view is, and they're all worthy of enormous praise. My own view is that the one project which pulls, as far as I can see, everything together is the artists' housing in Paris. So that's the one that I feel should get the prize, the overall prize. I was particularly impressed by the work that was done, or Rona did, on assessing the embodied energy particularly from the transport costs of transporting the timber, and where in France as a whole you could get the most economical energy from. It seemed a very interesting, wide-based approach. So my difficult choice, because they're all very good, the difficult choice is, I would say that Rona Bissett's scheme for Paris should get the overall prize.
just like to say thank you so much, everybody. Like, I was here yesterday and today, it's just been a great experience. I didn't really mind about running, but like, I got told about SEDA last semester, and like, I kind of feel like I found my path in architecture school, and like, being able to look at more sustainable designs, and also how my peers have found SEDA, and how they've also looked into sustainability and ecological designs. I feel like it's really helped like my course and everybody else, so I'm really thankful for everybody today and for Jim. Yeah, thank you.
I think we class this as a star among stars. Thank you very much.
Thank
and
you.
I knew Krystyna very well, and she'd be brilliant. Very thrilled.
Thank you.